All right, let's dive right in. Today we are going on a bit of a scientific detective story, a journey deep into the heart of the physics we thought we knew so well. We're going to start with the basics, the absolute bedrock of electricity and magnetism. You know, Maxwell's equations, and see if we can find a secret that's been hiding in plain sight this whole time.
And that really brings us to the main event, the big question. Are these famous equations, the very foundation of pretty much all our modern technology, really the complete picture? Or is there maybe a deeper layer, a hidden aspect of electromagnetism that we've just been kind of overlooking for more than a century?
So our first clue in this whole mystery, well, it comes from looking beyond the things we can actually measure. You know, like the electric and magnetic fields. We need to look at the concepts that actually create them in the first place.
Here's a really cool way to think about it. Picture the electric field E and the magnetic field B as just shadows on a wall. Yeah, they're real. You can definitely see their effects, but they aren't the fundamental objects themselves. They're actually cast by something deeper, something more primary, the electromagnetic potentials.
Okay, so let's get a little more specific. We've got the scalar potential, we call it phi, which is responsible for the static electric field, and then we have the vector potential, A, which is what generates the magnetic field. Now the key thing to get here is that the E and B fields we actually see and measure are just the result of how these hidden potentials are changing in space and time. They're basically just the rates of change of something way more fundamental.
So, what happens when physicists decide to rewrite Maxwell's equations using these more fundamental potentials? Well, something really curious happens. They stumble across this one mathematical term that for, well, over 100 years has pretty much been treated like a nuisance, something to just be swept under the rug.
Now we're not going to get bogged down in the math here. The process itself is pretty straightforward. You just take the equations we all know, you swap out E and B for their definitions based on the potentials, you do a little calculus, and boom, you get two new equations. But look at that last step, this one specific term, this weird combination of the divergence of A and the time derivative of phi, it just keeps popping up. It shows up in both new equations, tying them together.
In how has physics, traditionally dealt with this pesky term that keeps showing up? Well, just like the quote says, they just set it to zero. It's a mathematical choice called the Lorentz gauge. It's really just a convenience, a little trick that makes the equations way, way easier to solve. But what if, in that quest for making things simple, we've been throwing away something real?
So here it is, lay it out. The Lorentz gauge is basically a condition, you could almost call it a lock, that physicists put on the math. By just declaring that this whole chunk of an equation equals zero, those two really complex, tangled equations for the potentials just magically split into two simple separate wave equations. I mean, it's a really elegant solution, but you have to remember, it is based on an assumption that this term is and must always be zero.
Okay, this is where our detective story really takes a sharp turn. This is the moment where we ask the big what if. What if that assumption is wrong? What if that term isn't just some mathematical leftover you can ignore? What if it is a real physical field all on its own?
So let's give it a name. Let's call this thing S for scalar field. The idea here is that this isn't some condition you force to be zero. It's a new, living, breathing quantity, a third type of electromagnetic field that's been hiding inside Maxwell's equations this whole time. We haven't changed the equations one bit. We've just decided to stop ignoring a part of them.
Now, if S is a real field, the consequences are, well, they're fundamental. Classically, we're taught that charge density creates the scalar potential and current density creates the vector potential. Simple enough. But now, this new scalar field S, it becomes a source itself. A change in S over time can create scalar potential, and a change in S across space can create vector potential. It creates this beautiful new symmetry in the physics.
So the most important point is this. The scalar field basically acts like a bridge, a go-between for the two potentials. And this leads to something absolutely stunning. It means you can generate electromagnetic effects, waves of potential, without any charges or currents creating them. The scalar field itself can be the source, a concept that just doesn't exist in standard electrodynamics.
This
This unlocked physics, it predicts something truly revolutionary. It points to the existence of a totally new kind of wave, one that behaves completely differently from the light, the radio, the microwaves we all know and use every day.
And this is where the difference is just so clear. Standard electromagnetic waves are transverse. You know, the oscillation goes up and down while the wave moves forward, kind of like making a wave on a string. But these new waves, these are longitudinal. The oscillation is forwards and backwards in the same direction the wave is traveling, just like a sound wave. And what's really amazing is they can be purely electric, with no magnetic field at all.
So, you're probably asking, what's actually oscillating? What's waving? It's the potential itself. You can think of these longitudinal waves as pulses of compression and rarefaction, or, densification and depletion. They're basically waves of pressure and suction in this scalar potential field, pushing and pulling along their direction of travel.
So why does any of this matter? I mean, what's the so what? Well, if these waves are real, the technology that could come from them is staggering. I mean, imagine wireless power that can just pass right through thick shields, or communication that can travel through the earth or deep underwater where normal radio just dies, or completely new ways to move energy around that don't rely on normal radiation. The possibilities are they're transformative.
So let's pull all the pieces of our little detective story together. We started with the classic Maxwell's equations, we found an assumption that was made for convenience, and then we explored what happens if we just stop making that assumption.
And this really brings us to the ultimate takeaway. The physics in our textbooks isn't wrong, not at all. It just might be incomplete. You see, classical electromagnetism is really just a special case. It's the specific version of the theory where you choose to lock this hidden scalar field to zero. By unlocking it, by letting S be a real dynamic thing, we don't throw out the old physics. We just place it inside a much bigger, richer, and more complete picture.
And that leaves us with one final, pretty tantalizing thought. Is it possible that just by looking again at the math we've been using for over 100 years, we've stumbled upon a whole new dimension of reality? A hidden field that could unlock entirely new frontiers in energy, in communication, and in our basic understanding of how the universe works. That is the question this idea leaves us with.
Alright, so you see there is tons of calculus going on here. But let's get down to earth for a moment and talk about algebra next.
Let's talk about something that holds back even the smartest people from really succeeding in fields like engineering, physics, you name it. It's not about how smart you are, and it's not about passion. It's a single, fundamental roadblock that most people just don't see coming. So why is that? Why does someone who can grasp these incredible, complex theories in electronics or advanced mechanics suddenly hit a wall? What is this invisible barrier that just stops so many talented people right in their tracks? Well, this quote from a veteran engineer just hits the nail on the head. All of that incredibly advanced, mind-bending stuff, it's all built on the algebra you learned in high school. But here's the catch, and it's a big one. You can't just kind of know it. You have to really know it, inside and out. And that brings us to the main point here. The foundation isn't just important, it's everything. It's the bedrock that every single advanced skill is built upon. Let's break down why this is so unbelievably critical. Okay, so before you can even think about manipulating something like derivatives in calculus, you have to be an absolute wizard at shuffling equations around. And that's pure algebra, right? Or what about mastering imaginary units for electrical engineering? They're not just some weird abstract idea, they're a vital tool. And using them, yep, that depends entirely on how solid your algebra is. And then you've got vectors and polynomials in physics. That's the language of the field. Trying to work with them without a fluent command of algebra it's like trying to write a masterpiece novel when you don't even know the alphabet. So the bottom line is this. You need an absolutely unshakable foundation. When you're wrestling with some big, hairy, complex problem, the very last thing you want to be worried about is whether you made a simple algebra mistake. That right there, that is the hurdle. So if a shaky foundation is the real problem, what's the solution? Well, this is where a tool built specifically for this comes in. And today, we're going to look at one called Algebra because it's designed to fix this exact problem. So what is Algebra exactly? Think of it as a super comprehensive, high-end video series that's all about one thing, building your algebra foundation from the ground up so it's rock solid. It's not just a review, it's a complete rebuild. But here's the thing, Algebra isn't just a bunch of videos. It's a whole structured system, a method designed to get you to true mastery. Let's take a look at how the Algebra method actually works. The Algebra method really rests on these 4 pillars. First, it's guided learning. It's a journey where every single step logically builds on the last. Second, it's all about practical relevance, so you actually see how this stuff shapes the real world. Third, the explanations are amazing. They just break everything down into simple, digestible steps. And finally, you can track your progress with these cool interactive checkpoints, which really helps you stay on track. And like I said, this isn't just about watching videos. Algebra gives you a complete toolkit, everything you need to actually succeed. So what's in the box? With Algebra, you get interactive problem sets and quizzes to really sharpen your skills. You get downloadable reference materials, you get access to a community for support, and you get unlimited access to all 150 episodes. And you can watch them anywhere, on your phone, on your desktop, wherever. But on top of all those features, the people behind Algebra do something that really shows how much they believe in their program. It comes down to this number, 60. It's a 60-day, no questions asked money-back guarantee. I mean, that means there is literally zero risk for you. You can try Algebra, go through everything, and if it's not what you need, you get a full refund. It's really that simple. Okay, so if you're feeling like, yeah, this is me, my foundation needs work, Algebra has a few different ways you can get started. Let's look at the learning paths you can choose. You've got a few options here. The weekly plan is awesome if you just want to dip your toes in and see what Algebra is all about. If you're ready to commit a bit more, the intro or intermediate packs are great. And for those who are all in on total mastery, the full series gives you everything. It's really just about what works for your goals and, your budget. Look, the advanced stuff is the fun part. I get it. But it's mastering the fundamentals that really unlocks your potential. So please, don't let this one single hurdle hold you back from the future you want. You can fix this. The first step is super easy. Just head over to algeprime.com to check it out for yourself. That's ALGEPRIME.com. See if Algebra is the tool you need to finally build that foundation for good.
Thanks for watching to the end of this video. If you want more content like this, there is a playlist that should be popping up right now. Stay tuned for more. I've also made this free video for you with solutions for creativity, financial strength, and online security. I hope you'll enjoy this offer as well as all the others featured on my channel. And that concludes this video. Thanks for watching, and until next time, this is Hermalau Tube. My name is Konstantin, reminding you that your interest is the current that powers this channel.